This is the Professor, CBMD PhD, and today is Thursday, July 30th, 2026. It is 7:42 and 22 seconds p.m. Eastern Standard Time, and today's research, search for extraterrestrial intelligence. So let's hop to it here. Alien signals may be hiding where we rarely listen. Date July 30th, 2026. Source: Royal Astronomical Society. Astronomers may have been listening for alien civilizations in only a small slice of the radio spectrum while overlooking a largely unexplored range of higher frequencies. Using achieved data from the ALMA telescope in Chile, researchers conducted the observatory's first Seti survey, searching for narrow signals that could indicate advanced technology. No possible alien transmissions were found, but the study revealed that even a handful of telescope observations may quietly include millions of stars. Most radio Seti, search for extraterrestrial intelligence, projects have targeted frequencies between 1.42 and 1.66 gigahertz. This region is often called the water hole because it falls between the natural radio emissions produced by hydrogen and hydroxyl, which combine to form water. Researchers have long considered this quiet region of the spectrum a potentially logical meeting place for interstellar communication. An advanced civilization might recognize the importance of hydrogen and hydroxyl and choose to send or monitor signals there. New research now suggests that higher radio frequencies could offer another valuable place to search for technological signals from distant civilizations. Instead of requesting new telescope time, the researchers examined observations that had originally been collected for unrelated astronomy research. They searched the data for narrowband radio signals, which could be more consistent with artificial technology than with natural processes in space. For decades, SETI searches have concentrated on a relatively small part of the radio spectrum. We wanted to ask, what might happen if we looked somewhere very different? The millimeter and sub-millimeter radio bands remain almost completely unexplored for SETI, so this is really about opening up a new area of parameter space to search. The scientific investigators examined two narrow frequency ranges within ALMA's Band 3 observations. The search did not identify any candidate techno-signatures, alien signals, above the survey's detection thresholds. The project was limited to only 4 archived ALMA observations. Even so, the researchers say the results show that telescopes operating at higher radio frequencies could become useful tools in future SETI efforts. The study also draws attention to an often overlooked feature of radio astronomy. When a telescope is aimed at one object, its field of view usually includes many additional stars in the surrounding area. These unintentionally observed stars are sometimes described as stellar bycatch. Astronomers have traditionally estimated the amount of stellar bycatch in an observation by using star catalogs, such as Gaia. However, those catalogs may not include every star in the field, particularly objects that are extremely faint, distant, or difficult to identify with confidence. Researchers instead use the boson-Kahn galactic model, a simulation designed to estimate the distribution and characteristics of stars throughout the Milky Way. This allowed researchers to calculate the likely number of stars captured in each observation, including many that do not appear in existing catalogs. When the method was applied to an earlier SETI survey containing 1,327 telescope pointings, the estimated number of stars included in the search rose dramatically. Gaia data had identified about 288,000 stars, while the galactic model suggested that more than 6.1 million stars may actually have been observed. According to scientific investigations, the new estimate provides a more complete picture of how much of the Milky Way has already been examined for techno-signatures. One of the most exciting things about this work is realizing that we've surveyed many more stars than initially thought. Even a very small observation can contain a huge number and diversity of stars that we might never have intended to study. By combining high-frequency observations with galactic simulations, we can better understand exactly what we've searched and where we should look next. Astronomers and scientific investigators caution that the lack of detected signal should not be interpreted as evidence that intelligent life does not exist elsewhere. The search covered only a small number of observations at 2 limited frequency windows, and no candidate signal was found within those specific ranges. Instead, they hope the work will encourage astronomers to expand Seti surveys across a broader portion of the radio spectrum. It also shows how existing telescope archives can be reused to search for possible signs of technology without requiring entirely new observing campaigns. And this videography was created for educational purposes only. My code name is Will. I'm Professor Christopher Brunet, leader of research scientist, ufologist, psychic, computer technician, computer programmer, philanthropist, writer, mathematician, artist, photographer, film producer, chef, animal, and nature lover. My passion is world peace. Have a great day. This is a Professor, CBMD, PhD.